An intellectual property portfolio brings people to the table to come to resolution. It's like everything else. So what typically happens from an intellectual property dispute is something called a cross-license.
Okay.
So your competitor's got something, you've got something, you both want what the other has, so you effectively create a cross-license opportunity. So they can practice in a space that infringes on you, and
Right.
vice versa, and effectively then both of you are successful.
Now, coming out of that, the other point you're making about intellectual property strategy, in this case, it sounds like you have to know something about process. And I was mentioning to you early on, before we got started with the taping, I said, I think you may be our first company that's moving into production on the Michigan Innovators site. We've talked with all of these people who produce services or have productized services or who completely outsource their manufacturing and production, but you're not doing that. So maybe you could describe that strategy to us.
Sure. How to say this? When I left grad school, had a choice to go anywhere, literally, geographically. Wanted to stay in Michigan because I'm a Midwestern person.
Okay.
I mean, my aspirations in life are pretty simple. I want a company that has loading docks, meaning you're shipping product. And I want a company that has an opportunity for everybody to become a Microsoft millionaire. Because that means you are successful, right? Everyone has a chance to share. So when it came time to pick a site, we picked Michigan because of the proximity to Detroit and all of its automation resources, manufacturing, and the know-how here. In the fuel cell space, everyone's heard about fuel cells.
Right.
Everyone's read about fuel cells.
Right.
Everyone's excited about fuel cells. Politicians pontificate about fuel cells.
Right.
No one can buy a fuel cell. And one of the reasons why you can't buy a fuel cell is people can't figure out how to manufacture them cost effectively. And that was one of the big founding points of the company was we picked a fuel cell that's inherently low cost because we don't use platinum and we don't have to have hydrogen.
Right, you were mentioning that, material choice. Right.
So, as a material scientist, right, if you don't pick the cheapest raw material from the start, you're kind of limiting your opportunity, right? If you have platinum, the price will never go down for the system cheaper than that piece of platinum.
Right.
So for us, we pick ceramic powders that are inherently incredibly cheap. You can
Now,
buy them
now, there must be a trade-off there. Is there a performance trade-off there? Are people picking platinum because it gives them the best performance, or have they just not thought through the space enough or explored the space enough?
Oh, they've definitely thought through the space.
Okay.
Fuel cells are a lot like battery technologies. In fact, they are the same in a way. They're both electrochemical devices.
Okay.
Everyone's heard about batteries, right?
Right.
You've heard about a lead-acid battery
Yes.
in your car. It starts your car every time. You've heard about a lithium-ion battery in your laptop.
Right.
You've heard about a lithium polymer battery in your cell phone.
Right.
You've heard about a NiCad battery in your drill.
Right.
Every one of those is a very different cost and performance point. And neither one, and they all have their optimum markets, right?
Right.
You wouldn't use a lithium-ion battery to start your car because it would be very prohibitive and too big, right? But a lead-acid performs the function very well. You wouldn't carry a lead-acid battery with you to run your laptop because it's too big and too heavy.
Right.
Right? Fuel cells have the same thing. So, I mean, I don't want to malign the fuel cell industry as a whole. There are a couple different major fuel cell technologies. One of which is something called a PEM, a proton exchange membrane fuel cell.
Okay.
And that's the one almost everybody is familiar with because that's the one the automotive companies want to put in cars.
Okay.
So that's the hydrogen fuel cell.
Okay.
So if you have pure hydrogen, then this fuel cell, which just happens to run at low temperature and uses platinum as a catalyst, you can make a car function as with a fuel cell.
Okay.
Problem is that you need hydrogen,
Right.
and you need platinum.
Right.
The technology that we chose is something called it's a ceramic-based fuel cell called a solid oxide fuel cell.
Okay.
And we chose that technology 8 years ago because it's fuel flexible.
Okay.
So our fuel cell runs directly off things like propane and butane and all those little cylinders that you're familiar with when you go camping and hiking and hunting and ice fishing and all those other things, or you barbecue your food with.
Okay, so readily available. I mean, right now I'm not sure where I'd go to get hydrogen, to be honest with you.
You can't.
Okay.
It's just pretty much that simple. So we got a readily available fuel, and then we looked at the fuel cell technology that lets you do that as a ceramic-based fuel cell, and it just so happens we have the advantage of having very inexpensive raw materials in that there's no platinum involved.
Okay.
Now the price for this is our fuel cells made out of ceramic, which is a uniquely challenging material to form, fabricate, and manufacture.
Now, isn't one of your patents actually around the forming of the ceramic?
Yep, that was
Okay.
the first patent that got us started, as we realized we could make ceramics into a form that was conducive to fuel cells
Okay.
in a way that no one else could,
Okay.
which makes it cost effective and high volume. So we
Okay.
can make lots of fuel cells.
So that's the thing that's unique, because I was figuring, well, people must know about ceramic fuel cells. You know, I mean, it sort of sounded like a technology that was known the way you were describing it. But when we got into this formation idea, then suddenly, you know, little lights go off. And ceramics are notoriously hard to work with, actually.
Yes, they are.
Okay.
Yep, and the other thing we did is that we took a technology that was supported and driven by the Department of Energy to make megawatts. So these are fuel cells big enough to run a power plant, literally, and were developed by people like Honeywell and General Electric and Westinghouse, big companies. And we just took those core technologies and figured out how to shrink them down into a little tiny portable system you can carry around with you.
Okay.
And that was the other big push we had. So because we could make ceramics the way that we do with this extrusion process, suddenly we could make little micro scale ceramics, which would allow us to make tiny fuel cells instead of the huge gargantuan, you know, big as a tractor trailer type fuel cells built by the larger companies.
And so you were saying earlier 10x improvement, so go from carrying 20 to 30 pounds of batteries to carrying 2 or 3 pounds. So that means that this fuel cell is capable of producing 10 times the power?
Actually, it's 10 times the energy, but yes.
Okay. All right. Fascinating.
It is.
So let's so we're coming back to the manufacturing process. Okay, so you've got some unique components here that you're putting together, and you've actually figured out how to get them to work at a smaller scale. So what parts are you doing yourselves, and what parts are you having other people do?
Let's see. I'll try to use we build the fuel cell stack here.
Okay. Now, what is that?
A fuel cell stack, to use a good analogy, would be like the engine in your car.
Okay.
So we build the engine in the car here,
Okay.
and then we have suppliers that provide us things like electronics and controls, the housing, the box that the fuel cell goes into,
Okay.
pumps and fans and things that move air and fuel. Those types of things are purchase components for us.
Okay.
And we manufacture and develop the core value of the company, which is the fuel cell part.
Okay. Okay. So, so now you have recently, you're doing some of that here in the facility we're sitting in right now.
Absolutely.
Okay. And you've purchased or leasing or something another facility?
Yeah, we have about 3,000 square feet set aside today,
Okay.
where we treated it as a learning opportunity for how to make fuel cells. So we hired some people out of the automotive world who were very focused on manufacturing and scale up
Okay.
and didn't care about fuel cells, which was nice because we didn't have a technology champion. Instead, we had a manufacturing champion for how do you make more, how do you make it more reliable, how do you bring process under control, how do you institute Six Sigma, continuous improvement, right?
Right.
So we spent the last 12 months doing that here in 3,000 square feet, and we just acquired new space. I think it's, I'll call it roughly 40,000 square feet.
Okay.
So we're going to take the 3,000 square feet that we have today and scale it up to fit into 40, and correspondingly, you know, increase the amount that we make as yet another step in pilot scale production. So let us enter into first initial markets, you know, where a customer wants to buy 1,000 of something. We'll be
Okay.
able to provide that.
Okay, I was going to ask what kind of scales are we talking about here, and so that the 40,000 square foot facility gets you up to producing 1,000 for a particular customer.
Sure.
How much a year do you think you could produce in that facility?
Quite a bit.
Okay.
Quite a bit.
Okay.
We're just beginning to start looking at things like automation and semi-automation, which is it's amazing what a small footprint machine can do.
All right. All right. So ultimate scale not yet known.
Well, I mean, how do I say this? Batteries.
Yes.
They make billions of batteries every year.
Yes.
Billions of individual components. We're looking to enter into a small subset of that market.
Okay.
And so anything that you talk about volume-wise, number of unit sales, it has to be a pretty significant number to actually even matter.
Okay.
And that's exciting. So for us as a small business, as we grow, sales of 1,000 is easy. That doesn't even exist on the radar screen of a battery, right?
Right.
Tens of thousands, hundreds of thousands, and even millions of units, all very reasonable numbers.